So CrowdStrike released the report with what actually happened, preliminary post-incident review, what caused the issue. And it seems like they have some sort of content manager, file manager, that uploads new potential configurations of different threats in a binary file from the cloud into their system on the hard drive, on the local host. Now that update is convenient because you don't change the actual code of the program. You kind of just, feeding it different tapes, so to speak, so it can play through them and analyze based on them and understand them. Now their testing, they did multiple testing to earlier releases. So on February 28, 2024, Sensor 7.11 was made generally available to customers, introducing those new templates to detect novel attacks. So they loaded some templates, and those templates went through stress testing and were executed on a staging environment and a variety of operating systems and workloads. And then the template passed the stress test, everything looked good. Then on March 5th, the instance release following the successful stress test, an IPC template instance was released to production as part of the content configuration. So then they released that template, March 5th, probably without any issues or incidents. So they assumed subsequently 3 additional IPS templates. So more instances templates were deployed between April 8 and April 24. All of them also performed as expected in production. So they had multiple releases of a template of a new with a new sensor, I guess, or sensor, and the templates that they released to the sensor, multiple different templates. They all ran fine for 3 months. Now in July, they released 2 more templates, and due to the bug in the content validator, one of the 2 templates instances passed validation despite containing problematic content. So bug in the content validator, I would assume it's their automation tool, had an issue that didn't detect a problem and just marked it as pass. Based on the testing performed before, so they were relying on the earlier testing on the different templates, right? Even though they're feeding into the same program, just different templates considering they have like different configurations. They were trusting that the checks performed well based on the previous successful deployment of different versions of the configuration files that they feed. And looking at the content validator, so just looking at automation past, they deployed new instances into production. So pretty much it's lack of testing first, proper testing, and then lack of proper release strategies. When received by the sensor and loaded into the content interpreter, problematic content in channel file 291 resulted in an out-of-bounds memory read triggering an exception. This unexpected exception could not be gracefully handled, resulting in Windows operating system crash, BSOD, blue screen of death. So they released new software. That software was fed several configuration files that went fine, and then one configuration file didn't go well, and it passed the automatic verification, and based on the previous deployment, it was deployed. Before I go into how do we prevent this from happening again, I will tell you what would have caught it immediately. If they just had a team of manual testers reloading their files on, let's say they have you don't need a huge team, let's say 10 people, because they have multiple configuration and multiple systems, and they would have the 20 top use configuration that most of them going to include Windows for their customers in their lab where actual people test. So if they would preloaded this, it would crash immediately and they would caught it. That would have been caught right there. But then even let's say there was maybe something more advanced, and they would preloaded it and then went into their checklist for whatever the smoke testing for this would be. I don't know. Open the system, try to access something suspicious, download a virus, whatever the flow for verification of that would be. They would still probably caught it. It would still crash. It would still happen. But here, the root cause, well, relying on not enough process of deployment, that's one thing, but over-relying on automation is very problematic. Because if you automate everything 100%, what will save you from the bug within the automation itself? One day, automation goes crazy and passes all of the tests, and in fact, they're actually failing. You're looking at the report, it says all green and good, and then you deploy and you do $5 billion of damage. So it's not a good practice having everything just an automated pipeline, having everything so lean that it just goes through automation checks and auto deploys, especially when you're risking configuration of the system on that level that can break the whole system. And you manage millions of customers and you break their systems in a split second. That is not a good practice. So having at least one team of manual testers would have prevented this and detected it, right? And the second part of it is, we're getting into preventing this from happening, but the second part of it, we know that not all of the bugs can be caught. Even though this particular one would have been caught easily by manual testing. Now, not all the bugs can be caught, and the sum of the bugs that are not caught even with manual testing can be some corner cases, special scenarios. That is fine, but that will narrow down the scale of it because it's not an obvious thing that escapes. And also, if you have a process in place that will allow you canary deployment, so level by level, step by step deployment, and the process where you can roll things back, process where you can actually keep system running for a number of clients for several days until you see if there's any issue, read the report. So if you're managing multi-billion budgets and companies and people that you're responsible for the security and data, your outage can destroy a business. If your outage destroys someone's business, most likely they're going to go ahead and then try to get you for that and destroy yours business. So spending time on proper testing seems like the most important part, one of the most important part of the process that you may have. Like this is, I mean, great product, sure, that will be like 50%, but the other 50% making sure that that great product works as expected and doesn't messes up with your customers' data, right? Over here, looks like what happened was just over-reliance on automation. Automation itself had a bug, and here you go. That's what you got at the end. So how do they prevent this from happening? Software resiliency and testing. So they will improve rapid response content testing, so we'll test the configuration files more and use different testing types. Local developer testing. So this is going to be, now I don't disagree with local development testing. I think that's a good additional layer of verification, but local developer testing is very local towards developer's machine. You'll have to have a proper manual QA with different products that you use as a step in between your local developer testing and whatever environment, staging environment that you're releasing. There's no way around it. You can't just say we're going to have developers test it locally. This is not enough. Content update and rollback testing. This is good if this is something that they will be doing in the testing team, actually updating and then seeing if they can roll back successfully as part of the QA effort. I'm all for it. Stress testing, fuzzing, and fault injection. Okay. Stability testing. Okay. Content interface testing. Okay. All of that is fine. But I think you have to be very explicit here that you're actually adding some QA that will be looking at things and reporting things, and you're not going to be over-relying on automation tools any longer. Add additional validation checks on the content validator for rapid response content. A new check is in process to guard against this type of problematic content from being deployed in the future. Again, they're adding this to automation pipeline, which is good for verification in the future. But also, you have to have an actual live person looking at your deployment post factum, the QA that will spend some time doing some basic smoke testing, making sure it doesn't break the system. Because this thing was immediate after the update. So it's not like it's hard to catch. It's obviously in plain sight. It just over-reliance on your reporting that automation says all is good, and you just let it rip. Yeah, and go through your client systems. Then they will have deployment process update, which is very critical. So implement a staggering deployment strategy for rapid response content, in which updates are gradually deployed to larger portions of the sensor base, starting with a canary deployment. So canary deployment is deploying in small chunks, and again, how effective this is, you need to see how fast and how much they're deploying. Like in an ideal situation, you're probably going to deploy to 5% and give it a couple of days, then 10% a couple of days. So this is gradual deployment that should take about a couple of weeks in order to upgrade everyone. Improve monitoring for both sensor and system performance, collecting feedback during rapid response content, deployment to guide phased rollout. Sure, again, do not rely on over automating things. Also, with things like that, when you add more reporting, when you add more logs, you might also add more problems to your system, right? You might have logs that are faulty. You might have logs that are annoying and people will turn them off. You might have logs that introduce some data issues, right? Security issues. What exactly those logs are printing out? Who will have access to them? You know, sometimes you have logs and that print out things that you don't want to print. Not saying that it's going to happen, but this is just the nature of things. If you're implementing something, there's other things that need to go with it. Provide customers with greater control over the delivery of rapid response content updates by allowing granular selection of when and where these updates are deployed. That's actually pretty good, because then customer can take a risk by deploying something and just testing it out on one machine themselves, two machines. So you kind of giving customers here control and responsibility of proper deployment themselves, if they have a possibility not to upgrade everything and just do it in small batches. They'll probably will do it going from now on. Provide content update details via release notes, which customers can subscribe to. That is also, I think this is very interesting, how there was no content update on what goes into the patch before. And then they will have a third-party validation, conduct multiple independent third-party security code reviews. So they're going to hire third-party contractors. This is also kind of double-edged sword. Yes, but you can't over-rely on that. And how do you know that you're not introducing, some malicious factor? Like, essentially, if you get your code somewhere where it's not supposed to be by accident, or not by accident, but by choice, but you should understand the risk. If you're outsourcing something, if you're giving something away, you're also giving in a way for a risk to be, an attack from a third party now, because they now have access to look at your code, review your code. Conduct independent reviews of the end-to-end quality process from development through deployment. Yeah, well, I'm telling you this. Bring back some manual verification of your files when you deploy into the system, and some basic smoke checks that you do manually with real people looking at it, preferably in-house, not outsourcing it. Okay, so this is the summary of it. This is a striking example of how overlooking some simple things, some basic things in deployment and testing, can lead to catastrophe results. Hopefully you enjoyed this video. This was alexusadays, and bye-bye.